Okay guys, here we go, starting chapter 5. This is the identity sheet that you will find under lessons in your Trig on Blackboard. Make sure that you print one of these off and have it with you while you're doing your homework. You're really going to appreciate that later. You've already been through 3.1 and 3.2. You know these applications of radian measure, you know these conversions. And you guys really know, we've already talked about all of this in 5.1. All the fundamental identities in 5.1, you're already aware of. So we're going to review those fundamental identities in 5.1, and we are going to talk about how to use them as we move forward to start verifying identities. Okay, so make sure you have this where you have it handy so that you can refer to it while you do your homework. So when you use it on the test, you're going to be know where things are. 5.1, fundamental identities. An identity is an equation that is satisfied by every value in the domain of its variable. And we talked about the domain of the various functions. You know what is undefined in which function values. Then we're going to start looking at these fundamental identities. Like I said, you're already aware of these. Cotangent theta is the reciprocal of tangent. So cotangent is the same thing as 1 over tangent. Secant is the same thing as 1 over cosine theta, and cosecant theta is the same thing as 1 over sine theta. Then we have our quotient identities, because tangent theta is sine theta over cosine theta, and cotangent theta is the reciprocal of that, cosine theta over sine theta. Then we get to our 3 basic Pythagorean identities. Sine squared theta plus cosine squared theta is 1. You've got to remember these. Start committing these to memory. And then to develop the other 2, we developed all 3 back in section 1.4. When we were in section 1.4, we developed them all from our Pythagorean theorem, where x squared plus y squared equals r squared. And we started by dividing everything by r squared, and that's where we got to sine squared theta plus cosine squared theta equals 1. And then we divided everything by x squared and by y squared to get the other 2. Another way to get there, to develop these other 2 identities, are to take our main Pythagorean identity, sine squared theta plus cosine squared theta equals 1, and divide it by sine squared theta and then by cosine squared theta. So let's first divide everything by sine squared theta. When I do that, sine squared over sine squared is 1, plus cosine squared theta over sine squared theta is cotangent squared theta, and then 1 over sine squared theta is cosecant squared theta. So that is this 3rd Pythagorean identity. If I start back with my main Pythagorean identity, sine squared theta plus cosine squared theta equals 1, and this time I divide everything by cosine squared theta. Then I have tangent squared theta plus 1 equals secant squared theta. Tangent squared theta plus 1 equals secant squared theta. So there are my 3 Pythagorean identities. These identities have alternate forms, and we've talked about that as well. You're going to see the alternate form of these fundamental identities. For example, I can take my main Pythagorean identity and I can rearrange it. So if I move cosine squared theta over, I get sine squared theta equals 1 minus cosine squared theta, or I could move sine squared theta over instead. So for each of these main Pythagorean identities, I have alternate forms. You need to keep those in mind as we start verifying identities. The last section here under our fundamental identities are those negative angle identities. And this goes back to which functions are even and which functions are odd. These 2 functions, cosine and its reciprocal secant, are even functions. Even functions mean when I plug in the opposite of the domain, so in this case a negative theta, nothing happens. I get out the same as the original function. So cosine of negative theta is just the same thing as cosine theta. Secant of negative theta is just secant theta. I never leave a negative argument. I never leave a negative here. So I have to deal with it by either saying, oh, that's an even function, it goes away, or the other four functions are odd functions, which means sine of a negative theta is the same thing as the opposite of sine theta. Cosecant of negative theta is the opposite of cosecant theta, and the same is true for tangent and cotangent. Again, never leave a negative argument. Always deal with that by identifying whether you're working with an even or an odd function and acting accordingly. Maybe we need to make that note. Never leave a negative argument. Always deal with that negative argument. Okay, let's look at the next page. Now on the second page of 5.1 notes, you're going to see some things that you know how to do a different way. You guys know how to do this. If I give you cosine of angle theta and I tell you that cosine value is 5/8, well, you know that that is x over r because cosine is x over r, and you can sketch that and use that sketch to find y. And knowing that I'm in quadrant 4, we know that y is going to be negative. That's an important thing to note right there. Quadrant 4, sine theta is negative in quadrant 4. We're not going to do that. We're going to do what it says, and we are going to use our fundamental identities to find these other trig function values. For example, sine theta. Well, I have cosine, I need sine. The Pythagorean identity that ties those two together is sine theta plus cosine theta equals 1. Now, I want you to actually use these identities to help you solve, because this practice is what's going to save your bacon when you get on later on and need to verify the identities. Being able to practice using them seriously helps. Okay, plug in what you know. I do not know sine theta, so I'm going to leave sine squared theta. I do know cosine theta. Cosine theta is 5/8. So cosine squared theta is 5/8 squared, and that's equal to 1. I'm solving for sine. So I'm going to move this over. I need to square it, and I need to move it over. When I square it, it becomes 25/64. So I'm going to subtract 25/64 from both sides. Well, 1 is the same thing as 64/64, so I'm subtracting 25/64 from that. And what I'm left with is sine squared theta is equal to 39/64. Now, that's sine squared, not sine. I need to solve for sine. How do I solve for sine when I've got sine squared? Well, I take the square root of both sides. Now, typically, I would take plus or minus whenever I take the square root of both sides, because I have to consider that I don't know if that variable was positive or negative, except in this case, I have been told in the problem situation that I'm looking for a negative sine function value. So that is negative, and that blended together. That's negative. All right, so square root of sine squared is just sine theta. Square root of 39 does not simplify. It's just square root 39, but the square root of 64 is 8. So my result for sine theta is negative square root 39 over 8. Okay, let's do tangent theta. Tangent theta, I can use my quotient identity. Tangent theta is sine theta over cosine theta. Well, I just found sine theta, negative square root 39/8. Cosine theta was given to me as 5/8. That rational expression is just a big division problem where I use my larger fraction bar as my division symbol. When I divide by fractions, I multiply by the reciprocal. So that gives me negative square root 39/8 times 8/5. That 8 cancels out, and I got negative square root 39 over 5. Negative square root 39 over 5. And finally, I've got the secant of negative theta. Well, we know that secant theta is 1 over cosine theta. So, and we also know that secant is even. So secant of negative theta is just the same thing as secant theta. Secant theta is 1 over cosine theta, and cosine theta is 5/8 in this case. The reciprocal of 5/8 is 8/5. Okay, let's tackle the next one. On the next one, we are given tangent theta is a negative 5/3, and we're told that we're in quadrant 2. In quadrant 2, I'm sorry, I'm tired this morning. In quadrant 2, cosine is negative, sine is positive. So cosine negative, sine positive. That's how we end up with a negative value for tangent. All right, secant theta. I'm given tangent, I need secant, so I'm going to look back at my identity sheet and find an identity that ties together tangent and secant. My identity that ties together tangent and secant is the second Pythagorean identity. These are my 3 Pythagorean identities right there. Whoops, I started boxing the wrong one. These are my 3 Pythagorean identities right there. These are my quotient identities. These are my Pythagorean identities. So my second Pythagorean identity ties tangent and secant together. So that's the one I'm going to use. I am going to say I've got tangent square theta plus 1 is equal to secant square theta. That's what I know because that identity is a true statement. Let me make sure that I'm still in the frame of our video. We're close. Okay. So I'm going to plug in what I know. I know tangent. Tangent is negative 5/3 squared plus 1 equals secant square theta. Well, negative 5/3 squared is a positive 25/9, and I'm going to add 1 to that. Anytime I add and subtract fractions, I need a common denominator. So I'm going to rewrite 1 as 9/9. So what I end up with is 34/9 equal to secant square theta. Just like last time, I solved for secant by taking the square root of both sides. Secant is the reciprocal of cosine, and we know that we're in quadrant 2, so cosine is negative, so that's the sine, algebraic sign that I need out front here. Negative square root 34 over 3, because the square root of 9 is 3, is secant theta. There's that result. Now I'm going to do sine theta, and I want to use one of my fundamental identities to find sine theta. I know tangent, and I know cosine, because cosine is the reciprocal of secant. So if cosine theta is negative 3 over square root 34, and we're not going to mess with rationalizing that denominator until the end, because that may not remain my denominator. Since I know sine and cosine, I can use tangent theta equals sine theta over cosine theta to find sine. I know tangent is negative 5/3. I'm looking for sine theta. Cosine theta is negative 3 over square root 34. To find sine here, to solve for sine, I'm going to multiply by my denominator. Now, I'm not flipping it. I'm not dividing by it. I'm multiplying by the denominator to clear out that denominator. So I'm not taking the reciprocal here. That gives me sine theta is equal to, a negative times a negative is a positive. Sine is positive, that's correct. The 3's are going to cancel out. So I'm left with 5 over square root 34, and now is when I rationalize. When I rationalize that, I get 5 square roots of 34 over 34 is equal to sine theta. Again, I know you know other ways to do this, but you need to be using your identities to solve so that you're getting that practice using those identities. All right, cotangent of negative theta. Cotangent is an odd function. That's equal to the opposite of cotangent theta. And cotangent is the reciprocal of sine. That's my reciprocal identity. So that's a negative 1 over tangent. And I know that I was given tangent as negative 5/3. Well, a negative times a negative is a positive. I need to take the reciprocal, and I get cotangent as a positive 3/5. Cotangent of negative theta is a positive 3/5. Okay, to avoid a common error, when taking the square root, be sure to choose the algebraic sign based on the quadrant of theta. Pay close attention to what quadrant you're in. I strongly recommend that you tackle that algebraic sign first. Just like we did when we read those two problems, the very first thing we did was identify what quadrant I'm in and what that means for my cosine and sine function values. All right, let's look at that next page of notes. Example 2 says to write one trig function in the terms of the other. Now, pay close attention to what you're asked to do. I am not solving here. I am rewriting one function in terms of the other function. That means I'm starting with tangent theta and I'm going to end up with cosine theta, excuse me. Some things that you need to be aware of. As we move toward verifying identities, there are going to be multiple approaches. There's not just one way to do this. Lots of ways. Your goal is going to be to find connections among whatever functions you're working with, and then you're going to be manipulating the functions arithmetically. To do whatever task you've been given. Now, this does not always mean solve. In fact, one of the major things you're going to be told to do this chapter is to verify an identity. Two things. I'm not asking you whether or not it's an identity. The answer is not yes or no. It is an identity. You're going to show me how. Kind of like doing a geometric proof. This is always true. Show me how I get from one side to the other. The other thing, don't assume that you're solving. In these examples, we are not solving. We're taking tangent theta and we're rewriting it in terms of cosine theta using connections. We're finding connections between the functions. So I'm going to show you a couple of different ways to do this. Some ways are easier than others. Tangent to cosine. Well, I do not have an identity that gives me tangent to cosine. But if I look at my Pythagorean identities, I have tangent to secant, and secant is the reciprocal of cosine. So let's start here. Let's start with tangent square theta plus 1 equals secant square theta. And like I just said, secant is the reciprocal of cosine. And I want to solve for tangent in terms of cosine. I've got it down to just tangents and cosines, so I'm doing really, really well. I need to subtract that 1 from both sides. So I have tangent square theta equals 1 over cosine square theta minus 1. I need to get it into one expression. I've got two different terms here. I need one big rational expression. So I'm going to find that common denominator. I'm going to rewrite 1 as cosine square theta over cosine square theta. So now I've gotten it to tangent square theta equals 1 minus cosine square theta over cosine square theta because they have a common denominator. Now I'm going to stop really fast and just point out to you, you've got to keep that argument. You cannot drop off theta. It can be theta, it can be alpha, it can be x, it can be whatever you want it to be, but you have to have an argument there. Okay, so we've got tangent square. I need tangent in terms of cosine. So I need to solve for tangent. I'm going to solve for tangent by taking that square root. Now, this is just in general. I do not have a specific case. So when I take the square root, I have to consider both plus or minus. So what I end up with is tangent theta is equal to plus or minus square root of 1 minus cosine square theta, that numerator cannot be simplified, over cosine theta. That's my result. That's what tangent theta looks like in terms of cosine. Notice it's not simplified. It's just rewritten in a different set of terms. We are not always trying to simplify. Keep that in mind. Okay, another way to approach this. I could have started with the fact that tangent theta is equal to sine theta over cosine theta. This is approach number 1, this is approach number 2. You don't have to do this both ways. You just have to do it one way or the other. Now, I can't really do anything with this, but I can think about squaring both sides, and that gives me tangent square theta equals sine square theta over cosine square theta. And sine squared theta can be rewritten. If I look at my Pythagorean identity, if I move cosine squared theta over, that gives me sine squared theta. That's one of those alternate versions of that main Pythagorean identity. So I know that, little side note here, sine squared theta equals 1 minus cosine squared theta because of the Pythagorean identity. So I can make that substitution. I can say, okay, tangent squared theta equals, instead of sine squared theta is the same thing as 1 minus cosine squared theta, and now we are in the same place we were in over here. We've got the same place. So the next step is to take that square root, consider plus or minus, and we get the exact same result. So multiple approaches, you should get the same result no matter which approach you take. Okay, let's do another. We're going to write cosine x in terms of tangent x. So I need to find an identity linking cosine and tangent. You know what? That's the same thing. It's just I'm going the other direction. So I'm going to start with that same identity right here. And I'm going to say, notice that instead of theta, I'm using x. That's fine. I just need an argument there. I'm going to say, all right, let's do tangent square x plus 1 equals secant square x. Make sure you use whatever argument you're given. And secant is 1 over cosine. The way to move forward here, we're writing cosine in terms of tangent. I'm going to, what am I going to do? I'm going to multiply both sides by cosine to get that out of the denominator, because that's my first struggle, is to get cosine out of the denominator. So that I have cosine square x times tangent square x plus 1 equals 1. And then I need to divide this tangent square x plus 1 so that cosine is by itself. So I've got cosine square x is equal to 1 over tangent square x plus 1. Take the square root of both sides. When I take square root, I consider plus or minus because it can be in any quadrant. So I have cosine x, or excuse me, oh, I just switched to theta. Cosine x, sorry guys, cosine x, have it, is equal to, square root of 1 is just 1. So we've got plus or minus 1 over square root of tangent square x plus 1. I have to rationalize this denominator. So I'm going to go ahead and rationalize, and that is plus or minus square root tangent square x plus 1, all under that square root, over tangent square x plus 1, because I rationalized the denominator. So that's my result. That's cosine x in terms of tangent x. Or, that's one way to do it. Another approach to get to the same thing, I'm going to start at the same place, and I'm going to take the reciprocal of both sides. So here is your first tool. Some of you are sitting there going, oh my gosh, how did she know what to do? I had no clue what to do. Where do I pull that from? Well, this is why you're doing these notes. You're getting tools for your toolbox, literally. Remember we said that you are going to use multiple approaches for these. Well, first approach, find something that ties the trig functions together that you need. Second possible approach, you can take the reciprocal of both sides. That's a legal move. We're looking for things that are arithmetically legal. You're not going to mess up your equation. It works. And you're just going to try stuff until you find something that moves you forward. The thing that we are going to try now is taking the reciprocal of both sides. You didn't know to do that before. Now you know that that's a possibility. So we have 1 over tangent square x plus 1 is equal to 1 over secant square x And because secant and cosine are reciprocals, 1 over secant square x is the same thing as cosine square x. So I've just gotten to the same place, but I saved myself a little bit of work by taking this approach. Some approaches are more elegant than others. Some get you there more quickly than others. You're not going to know that until you have experience and you've tried a lot of different things and done a lot of practice. That's why we're going to have some written assignments for this chapter. All right, take the square root of both sides so that I can solve for cosine. That gets me this square root of this value, and that was right here. That's the same thing. We're at the same position right there. So we know we're going to have to simplify and we're going to have to rationalize so that we end up with plus or minus square root of tangent square x plus 1 over tangent square x plus 1 as cosine x written in terms of tangent x. All right. One more page of notes for 5-1. You guys know you can pause me. The beauty of online classes, having this video, is that you can pause me, you can rewind me, you can listen again, you can take your time to think through things as we're moving forward. Okay, same type of thing, but it looks a little bit more complex. We're rewriting an expression in terms of sine and cosine. That is another tool for your toolbox. This is a really good thing to try. If you don't know where to go, try that. Try to take whatever you're given and put it in terms of sine and cosine. Okay, here's our goal. We're going to use this tool. We're going to take our expression and we're going to write it in terms of sine and cosine. But our goal is to simplify so there are no quotients. So we're not going to have a fraction bar when we're done. We know we're done when we have no fraction bar. But our starting place is to use this tool of rewriting things in terms of sine and cosine. When I rewrite 1 plus tangent square theta in terms of sine and cosine, that's 1 plus sine square theta over cosine square theta. And then we know that secant is the reciprocal of cosine. I did what I was told to do. I rewrote it in terms of sine and cosine. Now my goal is to go from here to something that does not have a quotient. And I've got quotients all over the place. I've got this complex rational expression. I've got this big division symbol. I've got a little fraction bar in the numerator and the denominator. There are different ways to go about this. The simplest way to approach this is going to be to multiply the numerator and the denominator by that common denominator, cosine squared theta, which we could call a well-chosen 1. I'm going to multiply by cosine square theta over cosine square theta. Now, in my numerator, when I multiply in cosine square theta times 1 is cosine square theta. Cosine square theta times sine square theta over cosine square theta, those cosine squares are going to cancel out, and I'm left with sine square theta. In my denominator, cosine square theta times 1 is cosine square theta minus, and when I multiply right here, I get cosine square theta over itself, so that's minus 1. All right, what do I know that can help me keep simplifying this? I'm trying to get rid of this fraction bar, this quotient. Well, this is my Pythagorean identity. Cosine square theta plus sine square theta, that is 1. And my denominator, cosine square theta minus 1, think about that main Pythagorean identity that we just used in the numerator. Cosine square theta plus sine square theta equals 1. How does this relate to this? Well, if I move the 1 over, cosine square theta minus 1 is going to be equal to, move that over, negative sine square theta. So cosine square theta minus 1 is equal to negative sine square theta. You see how I took those two elements and I tied it to my Pythagorean identity. I tied it to that, and then I adjusted that identity to see what this would be equal to and made that substitution. All right, 1 over sine square theta. 1 over sine square theta is a reciprocal identity. 1 over sine square theta is cosecant square theta. Don't forget that negative. I've got negative cosecant square theta. That is simplified with no quotients. Make sure you keep in mind what your goal is. All right, let's do it again. I'm going to encourage you to pause the video. Use writing in terms of sine and cosine as your tool to simplify until you don't have any quotients. All right, you pause the video, but I'm going to keep going. We're using our Pythagorean, our main Pythagorean identity again. And simplifying. Okay, guys. Final note, and I've mentioned this a couple of times. When you are working with trig expressions and identities, be sure to write the argument of the function. You're going to get lazy, and instead of writing sine squared theta plus cosine squared theta equals 1, you want to do sine squared plus cosine squared equals 1, and that is wrong. That is incorrect. I will count that wrong. You will not get away with that on an exam. So make sure that you are taking the time to write the argument for each of your identities or function values.